Welcome to a new lecture in which we will present the input technologies enabling interaction in virtual or augmented reality environments. By the end of this lecture, you will have gained a fundamental understanding of input technologies, insight into current solutions, and an outlook on future perspectives. Input technologies are fundamental for creating immersive and intuitive experiences in virtual and augmented reality, enabling users to interact naturally with digital content and environments. These technologies analyze the status of the human body and interpret its changes to trigger specific commands. Different technologies can provide these functionalities, and choosing the option that best suits the application's aims is crucial. For this reason, it is important to be aware of existing input technologies. Devices like keyboards, mice, and touchscreens are not designed for immersive environments, and different solutions are needed. Now, let's start our overview of the technology solution for input with motion controllers. Motion controllers are handheld devices with various sensors that accurately track human hands' position, orientation, and movement. These devices typically include accelerometers, gyroscopes, and sometimes even infrared cameras which comprehensively understand the controller's location and orientation in three-dimensional space. Motion controllers enable users to interact highly intuitively and precisely with virtual environments by capturing hand movements. This level of precision allows for a wide range of applications, from gaming and entertainment to professional and educational uses. In professional situations, these controllers can be used for virtual training, simulation, remote surgeries, or complex design tasks in engineering and architecture. They often include various buttons, triggers, and touchpads to provide additional input options, further enriching the user's ability to interact with the virtual world. When physical controllers cannot be used, hand tracking and gesture recognition represent an excellent alternative. They use advanced cameras and sensors to capture and interpret the movement and position of the user's hands and fingers, eliminating the need for physical controllers. This technology leverages computer vision algorithms to accurately detect and analyze hand shapes, movement, and gestures. One of the primary benefits of hand tracking and gesture recognition is that they facilitate more natural and intuitive interactions by allowing users to manipulate virtual objects directly with their hands. In professional and industrial applications, hand tracking can be used for tasks requiring precision and agility. Operators can practice complex procedures with high realism, while engineering can manipulate 3D models in digital prototypes with exceptional accuracy. When users must enter complex commands on their hands are full, voice recognition becomes an effective input solution. Voice recognition allows users to interact using spoken language. Voice recognition can significantly enhance the user experience by translating spoken words into actionable inputs and providing an intuitive, hands-free methods of interaction. It can control various functionalities such as navigating menus, launching applications, manipulating virtual objects, and interacting with virtual characters. This interaction can streamline complex tasks and improve efficiency in professional applications, such as virtual meetings, training simulations, and remote collaborations. Input technologies can include other measurements of the human body, besides hands and voice, to enhance the interaction. Eye tracking, for instance, can simplify user interaction by enabling gaze-based control and providing insight into user attention. This technology involves sensors that monitor the user's gaze, direction, and eye movements. Objects can be selected or highlighted simply by looking at them. Menus can be navigated with the eyes, and virtual characters can respond to the user's gaze, creating a more immersive and intuitive experience. Another option is using biosensors to track physiological data, such as heart rate, brain activity, muscle activity, skin temperature, the galvanic skin response, and other biometric signals. Biosensors can create adaptive and responsive experiences based on the user's physical and emotional state, enhancing the technology's overall immersion and effectiveness. Future perspectives on input technologies will relate to multimodal interaction, which combines multiple input methods such as voice, gesture, eye tracking, and biosignals, allowing for flexible and effective input. Artificial intelligence will be relevant by enhancing input performance and enabling more intuitive, adaptive, and personalized experiences. Artificial intelligence can facilitate voice command interactions through natural language processing and the recognition of objects, gesture, facial expression, and emotions to create more immersive and interactive experiences. Predictive models will anticipate user actions and preference to dynamically adapt the simulated environment. In conclusion, by understanding and leveraging these innovative input technologies, you can create more immersive, intuitive, and practical applications, paving the way for significant advancement in professional and personal use cases.